The basic refrigeration cycle. A service technician needs a good understanding of the refrigeration cycle in order to diagnose a refrigerator, freezer, or air conditioner. Without this understanding, the technician will not be able to diagnose a sealed system problem correctly. Mechanical refrigeration is accomplished by continuously circulating, evaporating, and condensing a fixed supply of refrigerant in a closed system. Evaporation occurs at a low temperature and low pressure, while condensation occurs at a high temperature and high pressure. Thus, it is possible to transfer heat from an area of low temperature, that is, the refrigerator cabinet, to an area of high temperature, that is, the kitchen area. There are 5 components that make up the refrigeration cycle. They are 1. Compressor, 2. Condenser coil, 3. Metering device, 4. Evaporator coil, and 5. Refrigerant. Let's start the refrigeration cycle at the compressor. The compressor, also known as a vapor pump, is the heart of the refrigeration cycle. Once the compressor has started, the suction side of the compressor will draw in a superheated, low-pressure, low-temperature vapor refrigerant from the evaporator. This vapor is then compressed by the compressor piston into a high-pressure, high-temperature, and superheated vapor. When the refrigerant exits from the compressor discharge side and enters into the discharge line, it is a high-pressure, superheated vapor. The refrigerant will then travel to and enter the condenser coil, giving up some of its heat upon entry. The beginning portion of the condenser coil is often referred to as the desuperheating section, and the refrigerant is in the 100% vapor state. Around the middle of the condenser coil, the refrigerant gives up latent heat and begins to condense. At this point, the refrigerant state is 50% liquid and 50% vapor. As the refrigerant continues to travel and condense in the condenser coil, the liquid refrigerant increases, and the vapor refrigerant decreases. During this time, the refrigerant temperature remains stable. At the bottom of the condenser coil, the refrigerant will become 100% subcooled liquid, and the temperature of the refrigerant is also reduced. The subcooled refrigerant will prevent the refrigerant from boiling. The boiling of the refrigerant at the bottom of the condenser coil is known as flash gas. If this flash gas happens, the capacity of the sealed system would be reduced. To prevent this from happening, we must subcool the refrigerant before it reaches the metering device. The condenser coil's main purpose is to allow the refrigerant to give up its heat. As the refrigerant circulates through the condenser coil, the condenser fan motor will circulate the surrounding air through the condenser coil. As the air passes over the condenser coil, heat will transfer from the refrigerant to the surrounding air. Inside the condenser coil, the temperature of the high-pressure vapor refrigerant will determine the temperature at which condensation begins. Condensation usually begins when the refrigerant is approximately 30 degrees Fahrenheit higher than the surrounding air temperature. At that point, heat will transfer from the refrigerant to the surrounding air. The state of the refrigerant when it enters the liquid line is 100% liquid. The liquid refrigerant now enters the metering device. The flow of refrigerant into the evaporator is controlled by the pressure differential across the metering device. The metering device for refrigerators, freezers, residential ice machines, and room air conditioners is called the capillary tube. The capillary tube has a very small diameter opening at both ends. and is constructed out of copper tubing with a predetermined length. This type of metering device will control and measure the flow of refrigerant into the evaporator coil. The location of the metering device is at the end of the liquid line, before the inlet of the evaporator coil. Thus, the refrigerant tends to expand and evaporate. In order to evaporate, the liquid must absorb heat from the air passing over the evaporator coil. The liquid refrigerant in the evaporator coil will begin to boil and vaporize. This is called latent heat of vaporization. About midway in the evaporator coil, the state of the refrigerant is 50% liquid and 50% vapor. As the refrigerant moves through the evaporator coil, it goes from a saturated liquid to a more saturated vapor. When the refrigerant leaves the evaporator coil, it is superheated vapor. This superheated vapor returns to the compressor to begin the cycle over again. Eventually, the desired air temperature is reached, and the thermostat, or cold control, will break the electrical circuit to the compressor motor and stop the compressor. As the temperature of the air running through the evaporator rises, the thermostat re-establishes the electrical circuit. The compressor starts, and the refrigeration cycle continues. It is extremely important to analyze every system completely and understand the intended